everyone. In this video, we're just going to go through some of our basic terminology that we're going to be using through the whole semester in chemistry here, really the whole year. We're going to start by talking a little bit about the scientific method and then some different terminology and ways that we can define things and explain things in chemistry and in science in general. Our goal here is to be able to define chemistry as a science and to understand the scientific method and how we use it. So here's our definition of chemistry, and really this is what you can expect to be studying throughout this entire class. So it's a science that deals with the materials of the universe at an atomic scale. So here we're looking at materials at an atomic scale. So these are our keywords here that I would take down in my notes. So really thinking about atoms and how are atoms interacting, and then the changes that these materials go through. We're going to be talking a lot about this in this unit, as well as when we go forward. So really in all of chemistry, we're thinking about these changes. So a lot of times students come into class with this idea that we are going to be studying explosions and we're going to be blowing stuff up. And really what we're studying here is how is matter undergoing change and how are we observing that. Here we see our scientific method, and you guys should have a good understanding and a good idea of this at this point in your education. By now, I would expect that you have a general idea of what kind of the order of events is with the scientific method. So here we start, number one, or step one is always going to be making an observation. And when we look at this in science, we kind of look at something, and I like to think about, the way I like to think of it is I look at something and go, that's weird. I wonder why that happens. And through the scientific method, then we try to explain that phenomena. So first we have to make an observation. Once we've observed something, we can define a problem. So really come up with a way to kind of study this and then form a hypothesis and a prediction. So I can create a scientific experiment. I can try to take kind of an educated guess as to what the outcome of that experiment will be based on what I know. Then I'm going to do my experiment and collect data. Then we're going to analyze that data as evidence and then form conclusions based on that evidence. So this is important here. We're always going to be forming conclusions based on the evidence that we've collected. Okay, so our conclusion should always be supported by some sort of data and evidence. And you guys will see as we go through this class, as we work on different lab reports, this is really what you're going to be doing. Defining a problem, creating a hypothesis, creating an experiment to collect data, analyzing that data, and then forming some sort of conclusion from that. This video is shown below. I would just take a look at it. It's just a fun video, a clip from The Big Bang Theory, where Sheldon and Leonard are going through the scientific method in the comic book store. So it's just kind of fun. So the way that we go through the scientific method and parts of this, a really important part, especially in chemistry, is being able to make quality observations or making observations in general. So I just want to differentiate some key vocabulary here. So first we have an observation. This is anything that can be witnessed or recorded. So this can be something that I see, that I smell, that I taste, that I touch, anything that I can measure with a measuring device. These are going to be things that I'm observing in my experiment. Or really in the world around me. This is a little bit different from an inference. I noticed that students a lot want to kind of make a jump to inferences before really making a lot of quality observations first. So an inference, this is going to be our interpretation of what we observe. This is our explanation of what is happening. So here, if I look at this picture on the right over here, I notice that I have some object. This object is green in color. It has 1, 2, 3, 4, 5, 6 legs. It has 1, 2 antenna. All of these would be good observations for this particular object. My inference based on those observations, it has 6 legs, 2 antenna, and is green, would be that this object is a grasshopper. So there's kind of my differentiation. Things that I can see versus kind of a conclusion that I make based on that, what this object actually is. So there are some different types of observations that we can make as well. So quantitative versus qualitative. We're going to be making a lot of both of these types of observations in our labs, and really good data when we're looking at a lab experiment would include both qualitative and quantitative. So I really look at kind of the beginning of these words. Quantitative reminds me of quantity, which is a number. So this is going to be any sort of amount or quantity. Typically, these are going to be measurements of some kind. So the mass of something, the time that something takes, how much of something I have, or how many, the volume of something that I'm looking at. This is any numerical data. Whereas my qualitative, I think qualities, I look at the beginning of this word. This is going to describe kind of what my other senses can detect. So the physical makeup. What can I see, smell, taste, touch? In chemistry, we are never going to taste. We shouldn't put chemicals in our mouth. But we can make all sorts of other qualitative observations. So examples here would be something being soft, blue, round, rough, so kind of non-numerical observations. So here, if I look at this picture, I can see that I have orange, red, white, yellow, green, and purple items here. If I were to feel them, they might feel rough. If I tasted it, it might taste sweet. I can also make quantitative observations. I could take the mass of one of these objects. I can count how many that I have. I can take measurements of the size of the objects as well. So those would all be quantitative observations. Some different terms that we use or will be using a lot in chemistry for when we're making particularly qualitative observations are some of these things listed below. So we have luster. If something has luster or is lustrous, that means it's shiny. Translucent. Translucent means that light can pass through it. So if something is see-through or we can see through it, we'll call it translucent. We can frequently use this to describe different solutions that we see. Opaque would be the opposite of that. Opaque is going to be something that light can't pass through. So if you can't see through it, then that is opaque. For example, water is translucent, whereas milk is opaque. And then we have malleable. So malleability is how bendable something is, or if it can be hammered into a sheet without breaking. Really, we see this a lot with metals in particular. So malleable is another really good descriptive term that we see. All right, lastly here we have a couple of more terms that I want to talk about. So we have theory, natural laws. So really think and theories are not the same thing, and theories are really big important things in science. So a theory, a lot of times you think, oh, it's just a theory, or I've come up with a theory, and we see this a lot even in television and things. In science, theories are a big deal. So these are widely recognized and supported conclusions. They're going to be things that tell us why stuff happens. So this is an explanation of why. That's really important. And they're always going to be supported by lots of different observations. So our theories, they're supported by lots of experiments. Many scientists have done things, and they're going to be well recognized within the scientific community. And they're going to be well supported with all of the current experiments and data. That's not exactly the same as a law, and theories don't just eventually become laws. They're really two separate things. So theories are the why. Theory is going to explain why exactly that happened. And then we're going to talk about they're explaining why something happens, whereas laws are just telling us what is happening, okay? So if I drop my pen, it will fall to the ground. That would be the law of gravity, so explaining what is going to happen, whereas okay, so what versus why is my difference here. There's also a video down below on the page that will kind of go through those differences also. All right, so that wraps this up. If you guys have any questions, leave them in the comments, and I'll see you guys in class.